next for us, Jeremy?
Okay, thanks for coming back. Can everyone hear me? I don't have to bend over a little. Thanks for coming. I'd like to give a special thanks to Endow for funding this project, some federal entities for allowing me to conduct my research, my advisor for selecting me for this position. And I'd like to give a very special thanks to a lot of the technicians that have worked on my project and the people of rural Nevada. They've been particularly accommodating, and I've really enjoyed getting to know several. So a little bit about myself. I grew up in Missouri and graduated from the University of Missouri in 2007 with 2 bachelors, one in forestry, one in fisheries and wildlife. And before I had any sort of desire to come to Nevada and work with coyotes, I did wear a coyote as a tassel at my graduation. After that, I was a full-time trapper, fall, winter 2007 and 8. That's my barn catch right before I went and sold everything. And then soon after that, I went and worked in Hawaii with vertebrate pests, namely feral cats and pigs. I did that for about 2 years. And then I got this project, and now I work in Nevada with coyotes. I also have some other interests. I teach a workshop at the National Wildlife Society Conference, Animal Trapping Techniques for Researchers and Managers. I'm a member of several trapping organizations around the country, and I enjoy trapping part-time. While I'm a graduate student, I'll be honest, I've had less and less time for that. And recently, this recent May, I was in South Africa helping a graduate student who was working with black-backed jackals and caracals, which is actually a very similar system for being on the other side of the world to Nevada. The jackal's slightly smaller than a coyote, and the caracal's slightly larger than a bobcat, but they're both mesopredators, and they fill a very similar niche. But instead of wildlife, the real conflict is with livestock, particularly sheep. In fact, due to jackals and caracals, some of the farmers lose up to 50% of their lambs annually. So we were over there, and I was teaching trapping techniques, and I actually gave a similar talk to one I'm giving today to a lot of the farmers about coyote biology. And just a side note, I got to shoot an oryx, so that was pretty neat. So I like to say I wear 2 different hats, or I subscribe to 2 different kind of lines of thought. My academic hat, which I've been wearing more and more recently, but also my trapping hat, where I really like to get out and see the field and understand what's going on. And so while I like to spend my days doing things like this, more and more I've been staring at computer screens that look like this. And I can tell you that code, making sure your models are not over-dispersed, isn't overly fun. And so back to what I'm interested in with that trapping hat on. This is an individual from Pennsylvania that in a 2.5-month season caught 1,287 red fox by himself. And so I, as a scientist, but also as a trapper, have something to learn from this individual who never went to college, but obviously knows quite a bit about red fox biology, at least in Pennsylvania. And I throw this slide in. This is a supervisor from when I was in Hawaii. To fight biological invasions, you obviously have to be willing to kill for conservation. I do subscribe to lethal control at times, and I really like Tony Wasley's quote, "There's a time and place for predator control, but it isn't all the time in every place." And so I'm hoping to be able to really understand coyote biology a lot better and understand when and where lethal control is appropriate. And so some of my career interest is bridging what I see as a gap in science and trapper knowledge, particularly in predator control and invasive species work, refining management techniques, and looking at the science behind lethal control. So predator control is as old as the West. Europeaners started removing wolves as soon as they showed up on the East Coast, and that continued as man moved westward. But predator control and predator issues are certainly not unique to the West. I've met 2 graduate students working with white-tailed deer and coyotes in Georgia. It's a very similar story of consuming fawns and what impact that does or doesn't have, potential control or mitigation techniques. There's very similar issues in Sweden with the red fox and roe deer. The roe deer is a lot smaller than a mule deer, and the red foxes are actually slightly larger over there, so you have a lot of predation on fawns. And then finally, again, jackals and caracals in Africa. There is some concern with wildlife, but again, that's mainly with livestock. And finally, this certainly does happen in Nevada. Coyotes eat mule deer. But does the system look like this, or does it look like this? And I think that this isn't necessarily indicative of fauna here in Nevada, but it's really what we have going on. A very complex system and a computer malfunction. So two different philosophies on predator control would be year-round removal at a county or state landscape scale to try to reduce the overall population, or isolated removals during certain parts of the year to create temporary voids to benefit wildlife and or livestock. So let's talk about the Mule Deer Protection Act. I'm a Utah resident. In 2012 this was passed, and it generated $500,000 annually for a $50 bounty, and that money came, every big game tag sold now has an additional $5 added to it. And so this allows for, in theory at least, removal of 10,000 coyotes statewide. So in the first year, we saw over half of the money spent and 7,160 coyotes removed, which is a lot, but it's not as many as it might seem. And so if we start looking at what happened, less than 6% of the participants in the program killed over 25 coyotes. So a lot of people probably had a justification to go out and get new tires on their truck, a better varmint rifle, whatever. But as a lot of us know, coyotes are not the easiest quarry to pursue, and people were not nearly as successful as they had anticipated. And so if you look at the removal that occurred in the state the year prior to the bounty, over 5,000 coyotes were already removed from wildlife services, private predator removal, and fur trappers. And so with that, we had an additional somewhere between 3,000 and 4,800 coyotes removed. And so if you look at the coyotes that would have already died due to work and pursuits that would have happened, that cost somewhere between $79 and $126 per coyote. And I don't always like to put numbers on per animal units removed, but I think that that's important to keep in mind, that with a statewide bounty, there's already things removing. And I mean, as a trapper, when the grass is green, make hay, but it's not producing as much of a result as some might think. And so this is another point I like to make. 75% of the coyotes were removed before February 23rd. Really the best time to conduct coyote removal would be during the fawning season. And if you see these green points, they represent spots where coyotes are removed. You see a lot of removal occurring in and around towns and cities, which is not necessarily where mule deer fawning habitat occurs. So we look at the concept of additive mortality. This is a pretty easy concept to grasp, and I'll go to this example. Let's say we have 100 trout in this pond. Every one you remove is reducing one from the population. So if N is 100, your population is N. Every single animal you remove reduces that overall population. But then if we look at compensatory mortality, which is probably the story that goes on in most systems, it's a lot harder to understand. It's also a lot harder to convey. And so I highlighted here, for every life taken, a life is saved. And we can use muskrats as an example. Let's say that there's 100 muskrats in this marsh, and something limits that population. And so 20 to 25 might die per season. And that might be due to food, it might be due to space for huts, something like this. If a trapper comes in and removes 25 of these individuals, that can free up that resource, be it food, hut space, whatever, and allow those additional individuals to survive. This is what allows us to have hunting seasons to take basically that surplus from the population every year. So back to coyotes. What we do know about coyote biology is 75% of a population has to be removed every year for 15 years at a landscape scale to start seeing a reduction in the population, and only 10% of the pups have to survive to reproduce once to maintain a population. And mule deer are most susceptible to coyote predation in the first month of their life. We also know as you kill more coyotes, the reproduction increases, and you see that with more females breeding, more pups per female, coyotes breeding at a younger age, particularly the 1-year-olds, and immigration increasing. I know if you were here at the last time I spoke, I don't have this slide, I had a coyote that was collared in the tops of the the Tequimas, lived in Smoky Valley for a while, and then in a 30-hour period traveled 49 kilometers and remained in Grass Valley until he was shot by a hunter. Distribution and size, it's a pretty successful animal. If you see this is the original home range of coyotes, and with the extirpation of the wolf and some other things that occurred, we now see coyotes really occurring all of North America. And these are all the same species. I like this slide. Coyotes eat everything but the kitchen sink, but at least at one point they have eaten out of a kitchen sink. They've been documented crossing the Golden Gate Bridge in San Francisco, and they can survive on anything from trash to exclusively meat to almost an entirely herbivorous diet. So my research questions: what is the diet of coyotes in central Nevada, and does it change from season to season and year to year? And how do the changes in availability of lagomorphs and small mammals do or do not show up in coyote diet? And how does prey availability potentially affect microhabitat selection? So what have I done thus far? I've collared 30 coyotes, ear tagged 22 pups, and then when the pups were large enough, we put out 3 just VHF collars. We've conducted small mammal trapping in 2012 and 13, and actually spring 2014. And then we've been doing lagomorph surveys and scat surveys the last 4 years as well. So the changes in technology, if anyone here ever goes to graduate school and conducts any sort of a GPS collar study, I can guarantee you that you will wish that your study began at the end just because of the changes in the technology. It's really been mind-boggling how much these collars have increased. They've decreased in weight, they've decreased in price, they've increased in longevity, and really since 2010. And so I started out with store-on boards, which emit a VHF frequency. We're supposed to stay on the animals 2 years and then drop off, emit a VHF frequency, and then we go pick it up, hook it up to the computer, and get the points. Unfortunately, we had about an 80% failure rate on the drop-off device, and they fell out prematurely. And if an animal disappears, disperses, I don't know where it goes unless we can find it with telemetry equipment. So in the last couple of years, iridium equipment has become much more affordable, and that communicates with satellites that I can log into my computer and see what's going on, and we can almost get real-time data. We can change how many points the collars do or don't collect per day, and it also allows us to ask some additional questions since we're almost getting live time what these animals are doing instead of waiting 2 years to get it back. So if we look at coyote survival, coyotes that I've tagged, 5 have been shot by hunters. 2 pups that I've ear tagged have showed up on the California-Nevada border, also shot by hunters. They were collared just south of Austin in the Toyabes and were shot in turn pivot fields. And another coyote died of natural causes. And then just a couple weeks ago, we found this animal that had been eaten by a mountain lion. And 3 collars are missing. So talking about coyote home ranges, this is the oldest way to estimate a home range, and this is called an MCP, or minimum convex polygon. It's really straightforward. All you do is you connect the lines for the furthest dots. This is known as an adaptive kernel. It has an algorithm running in the background, and it takes into account proximity from one point to the next, and so it actually excludes this area as important home range. And so the animal was here at one point, but it doesn't seem to be an important component of that animal's home range. And so I like to point this out. If you look at the square kilometers of this polygon, it's 93, and then if you look at the darkest blue on the outside, that's known as the 99 adaptive kernel. So that's 99% of where the animal was since it had this collar on, and I think that that tells a much more accurate story. However, due to maps and just seeing where all the different coyotes are, I am going to use these minimum convex polygons. So here are the 8 collars that I've either received this season or are still currently transmitting data that we will be going and collecting additional information on. So some things that are interesting, I'll go into detail. Up here, these 2 are actually a male-female combo with a den, and then this is a bordering animal, and this was a disperser, so it actually was moving its entire life, and this is the one that was actually eaten by the mountain lion right about there. So here's the male-female minimum convex polygon. The red is the female, and the blue is the male. It's a very similar home range, not surprising at all that the male has a slightly larger territory. And here are the adaptive kernels. So you can see these different shades of blue. This is the 99%, the 95, the 75, and the 25% home ranges. And so you can see this is the den, and then this provided some other sort of resources that the male went to more than the female. And finally, this is an animal that has had a collar out for 2 years. I think this is fascinating. Blue This animal was collared, I believe, January 13th, 2013. This is its entire home range for 2013, and this is its entire home range for 2014. So, given the whole year hasn't gone by, but it's pretty fascinating to me that this difference in space use, and will allow for some additional questions. So, small mammal trapping to get an understanding of the density and abundance of small mammals on the landscape. So we run 296 Shermans per site per night, which totals 3,552 trap nights per season. It's pretty robust, allow for some accurate estimates. These are the raw counts of the data, and you can see here in spring 2012 we either captured or recaptured. I should mention that these are small mammal encounters, so an individual could be captured up to 3 times. Anyway, we had about 1,600. We saw quite a bit of a drop into the fall. We saw really an order of a magnitude change from spring 2012 to spring 2013, and then a slight increase into the fall. And I've talked to hunters in my areas, and they've seen this as well. They say that some hunting seasons they'll actually bring a BB gun into camp just to shoot the mice that are crawling on coolers and everything. And so I know that a deer mouse are the most common, and that this is a very small individual. They're very rarely over 20 grams, which is very small, but if you extrapolate that out over the landscape, it's a huge amount of prey, or biomass available to all predators, and there's a huge change in a prey base from one year to the next. We're also doing lagomorph surveys. Rabbits are a little harder to get a hold of or handle on, density and abundance-wise. And so every 2 weeks, according with the new moon and the full moon, we drive approximately 10 miles in each of my 4 study sites, and there's a driver on, a spotter on each side in the back with spotlights, and then the driver watching the road. And then when you see a jackrabbit, you stop. You identify if it's a jackrabbit cotton-tailored pygmy, and then you use a rangefinder to get the distance from the road, and that'll allow for distance estimates. Lagomorph detections, I guess I should have explained lagomorphs and rabbits are the same thing. There is a difference between 2012 and 2013, not nearly as large, though, as the small mammals. And so we also walk these scat transects. There's 4 kilometers of transects in each of my study sites to pick up coyote scat for an abundance estimate, but also for a diet estimate. And you know, when I run into people, for some reason, people are really entertained by the fact that we pick up coyote scats and break them apart and tell what's in there. I mean, say it's a crappy job, but somebody has to do it. But you can really tell a lot about what's going on. So you should reconsider the scientific validity of scats. So various items that we've found. There's a whole slew of rodents. There are deer. There was 1 skunk, and there's actually quite a bit of parts that we just can't tell because it's so digested. So the scat summaries, we've washed 304 so far. That process, just in case you're wondering, you take a pantyhose, cut it in half. 1 scat goes in 1 pantyhose. You soak that in a bucket overnight, and then throw it in a washing machine for 2 or 3 washes, and that removes that meat base and leaves behind those bones and hair. And it was actually quite a fiasco to find a washing machine that I could use to do this. A committee member of mine, and I asked if she knew anywhere I could go. She said, "Well, laundromats are open 24 hours," but I didn't do that. So you can see these percentages represent the largest majority of prey in the scat. So there were many times where there were 2 or even 3 different species, but these were just taken from the first column of the majority. So we can see that lagomorphs compose 35%. I combined all rodents. I'll probably have to do that for the analysis. And then deer were in 19% of the scats, and there was an increase in deer hair in scats after the fawning season, indicating, though not necessarily proving, that there is an increase in deer consumption once fawns hit the ground. And then there's 16% of just plant parts, a few with feathers, not nearly as many sage-grouse feathers as I expected, that make up that final 16%. So this microhabitat analysis, these iridium collars that allow us to go back and look where coyotes have been, and we're doing this during the denning and pup rearing season. So we're randomly choosing 30 points that these coyotes have been during this season, which is April to the end of July. And when we go to these, we collect 22 different variables. I haven't done any analysis on this yet, but just going out in the field and doing this, I can tell you that not all coyotes are created equal. I've been on one that just loved to run the tops of ridges, go to the highest, craziest points, and I've been following another coyote that loved mountain mahogany. And I can tell you that those are not very fun plots to do. And then we're also using this iridium data to go to as many dens as possible to collect data on habitat selection for den sites. So the project deliverables: how does diet change with prey abundance? What is the abundance of coyotes in central Nevada? Their productivity, their mortality and/or survival rates, their home range sizes, and what types of habitat are used by coyotes during the pup rearing season. And with that, any questions? Okay. Yes.
You said that the one coyote that you collared had moved 49 kilometers. Do you have any idea what those coyotes?
I do not have a clue. I know from reading the literature, the question was what would drive a coyote to make it move 49 kilometers in 30 hours. That was in early spring. You know, there's always going to be a portion of any coyote population that just have dispersers that just move their entire lives. This guy was 3 years old. He was abnormally large. He was a male. Lived high up in the mountains for a while. Did the same thing in a valley and then moved to another valley. So there's a long list of potential reasons, but I couldn't tell you why he did it.
I have one other question. Can you quantify how many more coyotes are born when you control coyotes? You said it increases the...
There's a paper published by Fred Knowlton in 1972 that looks at the number of placental scars. So that's the number of eggs that landed on the placenta. I'm sorry, on the reproductive tract. And the average for coyotes pretty much nationwide is 5.5 pups, and there was an increase to 7.5 or 8 with an increase in a study in Texas.
Yeah, those are older, so I'm talking about your study.
I haven't. I won't have that information. I haven't either dissected my live animals for obvious reasons, and I don't have the medical equipment to look to see what their uterine swellings are.
Any commissioners have any questions?
You can. I'll be here all day, so feel free to come up and talk to me too.
Thank you very much.
Thanks, Pat.